Like I just said, I added readings that to go over nested iteration. So we are going to be covering something because I was checking and like, wait a second, I need to cover this. Why haven't I covered this before? I thought I did. And we kind of been covering it abstractly, but never really had to tackle things that are like lists of lists yet or anything like that. So we're going to take a look at that by actually looking at images. Now, I'll be doing this I'll be starting here in the nested iteration image processing because honestly, this is a good way to start thinking about it. Right? So I'm dealing with two-dimensional images. We are going to be using something called CImage. And as it says, you can use this. This supports image over here. But if you want to if you want to actually, work on your own computer, you'll have to install it yourself. Let's see, can we create images? Create image with CImage. Can we do that? Actually, Python, because this is, and original, we can get a file image with this. We can do quite a bit with this, actually. Image type supported, JPEG, GIF, TIFF, PNG. So not going to give you high performance operations. It allows you to read an image and manipulate its pixels. Then you can save the new image to a file or display the image in a window. It's about really it. But that's all you really want to do if you're teaching an introductory computer science course, which is fantastic. Right, so let's take a look at an example program with this. Right, or rather over here, let's just go ahead and talk about what is an image and how the computers display things. Right, so we've seen, and I got to thinking about this because I got a chance to go to a museum, and one of my favorite American artists is Edwin Church. And Google does all these beautiful high-res scans of these images. Now, this image is 1.4 megabytes, which is smaller than the complete works of Shakespeare. And as you can see, as we zoom in, it gets a bit pixelated, as we like to say. Actually, it seems to be doing some what's called anti-aliasing as well, as on this end of the machine, because, so let's see, preferences, smooth images when zoomed in, no. That was called anti-aliasing. As we zoom in, you can let's see if I can't get to something a bit more easier to see on the whiteboard, or sorry, on the board. So let's go over here. Right? Everybody, so hopefully you can see, but this image is made up of little itty bitty squares. In fact, it's made up of 5,176 by 2874 little squares, which if we throw that into Python's calculation function, 5076 times 2874, that is 14.5 million tiny squares, okay? Now, before I checked it, it was doing something called anti-aliasing, which is, it was just smoothing it out to make it look a bit less blocky, but I don't want to do that. So the idea here is that we just basically don't see these little blocks. We actually kind of just see it as a whole thing, because, our eyes can only see so much. But computer basically will just simply display a bunch of pictures. Now, the most common form now most displays, they are 1080p displays or 1920 by 1080, which means that most monitors display and it will constantly display an image to you that has, let's see, well, Python 3, 1920 by 1080. This is the normal, so this is 2 million pixels. So most of the time, the laptop in front of you most likely is displaying 2 million pixels to you right now. And most laptops run at 60 hertz. The higher end ones might run at 120, but 60, if it's running at 60 hertz like mine is, that means it's displaying 2 million pixels to you 60 times a second. That's how fast it is able to update and push that out to you. So, so considering that we're using this to see, it's kind of an idea to know what these, how this works. So 2D tables, as we'll see, or 2D lists, or we get into Excel files. Once we get into Excel files and spreadsheets, they have two-dimensional stuff. They have rows and columns. So turns out, though, that rows and columns are also used for digital images. So we are going to be using, so a digital image is just all these small little things made up of what we call pixels, small picture elements, right? And those are just a little splat of color, okay? And so this is what we might see as an image. So each image has its own width and own height, which is basically the number of columns and number width. And what's unique is that we start counting at this corner over here, right? It's not a standard coordinate plane, right? Normally with a coordinate plane, right? And I think I've told you before, normally in a coordinate plane, we're either thinking of this as the center, or is this or 0, 0 being the bottom left corner. But in computer science, this is 0, 0 in the top left corner. So we're working in this quadrant over here. So this is a pixel of row R and column C. So, and again, we're getting back to what we call the RGB model, red, green, blue. So, so if we set red to 0, there's no red intensity. Maximum intensity is 255. So we can take a look at, and so what we're going to use is some in the library called image to manipulate this, to deal with pixels and manipulate images. You can do it in the browser here, but if you want to install it on your computer to work with it, what you'll need to type in is either pip or pip3. Most likely pip3. Pip3 install C and capital I image, which I've already done on my computer, okay, to work with it locally. Okay, so pixels are pretty straightforward. They have, they're just small little objects, which are collections of multiple variables, okay? They're collection, so an object is a small collection of variables and also things you can do with that variable. And basically, a pixel has only 3 things we care about: red, greens, and blues. How much red, how much green, and how much blue. So we can use a bunch of functions that are already written to do this. So, for instance, we can run this. So this is our standard hello world, where basically we say we have this image, and we can say, hey, I want to create a new pixel like this, image.pixel, which has 45 red, 76 blue, 76 green, and 200 blue. So we run it, and it says, how much red is there? There's 45 red. Change the amount of red to 66. How much red is there? There's 66. Change the amount of blue to be equal to the amount of green. And then we print out green and blue, and we'll get it. If we print out P itself, if we print out the pixel itself, we'll see that it prints out as small list. So if we've got something with RGB, what is it going to be? 50. It's going to be light red or dark red? Let's see. Dark red? Yep. Because all three values are close to 0, it will appear to be dark. So, but honestly, dealing with individual pixels are a pain. So in a real image, we would want to create our image object first. So the first thing we can do is that we can make it from we can get an image object from an image that already exists on our computer. It's also to create an empty image that has a width and a height, but only is made up of white pixels. So what we can do is that we can say, over here, let's see. So let's go ahead and actually play with this over here. So my image dot, yeah. So let's go ahead and see if I can't figure this out from here. So let's go into Classroom, ITP, create image dot py. So we're going to import image. And then we're going to say our my pick is equal to image.empty. Let's go ahead and take a look at all these things that are over here. Always work with the documentation over here. Image.empty image 100 by 200. Or let's make a 100 by 100 picture. So this is 100 by 100 pixels. Much, much smaller than the masterpiece that we were looking at from church. So my pick is equal to this. And this will basically create a new picture that has all white pixels. Okay. So what we can do is maybe let's go ahead and change. And what we could do is that we could say, hey, and what we can, and again, this is made up of a lot of pixels. So let's run this to make sure it works. Print my pick is equal to what? It's going to say an image object. So, and then what we can do is we can start modifying this picture by saying, hey, set pixel. Well, let's make a pixel. P is equal to let's see, image dot pixel, I believe. 100. Let's go ahead and make it all red. 255, 0, 0. Very intense red. Set pixel 100. So we're going to set the upper left corner of the picture, 0, 0, to be P, to be that red color. So now how do I display that picture? That's an excellent question. I should probably figure that out. It says maybe if I run it, let's see, make sure I'm not getting any errors. Let's go with my pick dot draw. And let's see, do I have win? So I need to set up a window for it to go in before I can do anything. So window, let's create a 48 by 6400 image processing window. Let's go ahead and say draw this onto the window. And let's see how bad that works. It did not work in the slightest. Oh, it stopped. Exit on click. There we go. Okay. It is impossible for you to see, but I can see it. But here's what we did. We have a picture. Here's my 100 by 100 white picture, right? And up here on the top corner, this little bitty top corner is an little bitty bit of red. It's nearly impossible to see because it's one pixel. You cannot really make out one pixel. Although if you have a dead pixel on your computer, it will annoy you like nothing else. Okay? Okay, so a couple of magic phrases happened over here. This just simply created the window, image.image window. It's 48 by 6400. Honestly, that's the wrong aspect ratio for it. 6400 by 4800. Right? The first number is how wide I would like it to be. How wide X, but also how many columns. And the second number is how many rows do I want. Right? And notice that basically this is 100 by 100, so it's much smaller. So, let's go ahead and maybe do something a bit more involved with this. Rather than setting one pixel, we should probably set a bunch of pixels. Right? So maybe we can set the entire, maybe like an entire line of pixels. Right? Yes?
What does the mind think that set pixel?
This changes one of the pixels to be a red pixel. So I'm going to change this to red. Red pixel. Right? And then what I do, and what this does, this sets 0, 0 to the red pixel. It sets one pixel to that red pixel. And it's nearly impossible to see because that's all it is right over there. Top left corner. But it's only one pixel on my computer. So we need to change a lot of pixels if we want to do it, if we want to make a difference. So maybe a diagonal line might be easier to see, like if I were to do 1, 1. Okay, I can see it over here, but you can't see it. But, so obviously, wait, if I'm copying and pasting a lot and doing the same thing over and over again, should use a for loop for that, right? So for I in range 0 to up to, but not including 100, let's set this equal to I. Oh, can everybody see that diagonal line going through it now? Right? So why is it a diagonal line? Because I'm saying set 0, 0. 0, 0. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. So, yep, the first two parameters are the coordinates. The x-coordinate and the y-coordinate. Here, the x-coordinate works exactly as you'd expect, but the y-coordinate goes down. So if I, for instance, set this to 50, we get a vertical line, right? Or this horizontal line going across. Because the x changes, but the y doesn't. Is anybody confused about the coordinates right now? Okay, right over here we're changing, setting I. We're changing all the pixels in, or rather we're changing a bunch of the pixels. We're changing 100 of them. All of them are the same y coordinate, but we're changing all these guys to the red pixel. So we're changing 050 to the red pixel, 150 to the red pixel, 250 to the red pixel, 350 to the red pixel, 450, 550, 650, and so on and so forth, until we get to 160. All right. So now what's important is that when we're working with two-dimensional things, as we get into tables, you need to remember whether you're working in X, Y, or row column. That is very important because they're completely the opposite of in terms of which you do for like do you go up, down or across first. And right now we're working in X, Y. Right? So we can create an image like this, fairly straightforward. So let's go back to our examples here. But honestly, I'm not the greatest artist. What we can do is that we can load up any image on our computer. So here, there's an image stored called luther.jpg that has the Luther College bell on here. Okay? We can get how big it is, the image width and height, which is 400 width, 244 height. We can get the pixel 45. Sorry, we can get the pixel at 4555, which is probably somewhere around here, and then get its color values over here. Okay. Now, what we can do over here, so let's go ahead and, now what we're going to need to do here is a lot of nested iteration, right? Where basically we have an outer for loop and an inner for loop like we've seen before. And you should have seen this, and we've done this before, but basically what we're going to do is we're going to have two variables that change, right? And the big thing to remember here is that, remember, the I value only changes after it's done, the I value changes a lot slower than the inner one, right? We run through all the values for the inner one, then we increment the outer one once. Then we run through all the values for the inner one, and then we increment the outer value once. Then we run through all the values for the inner one, and increment the outer value once. And if you're having trouble, there's this, nice visualization that goes on over here. That's built into the textbook. So what we can do is we can basically say, hey, for our image over here, for x in image dot get width, right? So let's just go ahead and print out x. And this will get me all the x coordinates. Image has no attribute get width. What am I doing wrong? Oh, I called it the wrong variable. It's not image. It's my pick dot get width. Print out x. Int is not iterable. In range. So for all the x's, so for all the x coordinates, 0 to 99. And then for all the possible y coordinates, for y in range, my pick got height. Right? Let's go ahead and comment this out over here, comment this out over here. And what we've got is that we can do x comma y, and this is going to print out all the possible x, y combinations that exist. Right? These are all the possible x, y combinations that exist. And so what we can do here, right, this is all the possible combinations, right? We go through 100 by 100. So what we can do is now we can have some fun with this picture. We can say, hey, I would like to, let's say, get, we can change this to a black picture fairly easily by saying, hey, my pick dot set pixel. What x and y do we want to set it to? Well, we already have an x and y that we're iterating over. And then we can say image dot pixel to create a new pixel here. And 255, sorry, 0, 0, 0. Uncomment these, delete, delete, and need a close brace over here. And what we get is now we have a completely black picture over here. If we instead set this to, let's see, 0 or 255 over here, we can set it to a completely green picture over here. Every pixel set to green. In fact, I can always add a little bit of red over here. Doesn't really show up that much. what I could do is add in some more, maybe 200 red. And there we go. And so now kind of this yellowish teal thing. So we can go through this, but that's not really exciting because honestly, I have no idea what I've got. So let's go ahead and instead of playing with this, we will play with my picture. So I'm going to copy this into my GitHub directory, classroom. Or honestly, let's go ahead and look for a smaller picture that's easier to work with. Let's go with here. Oh, I know one. Shocked Pikachu. Okay, image. Just simply grab this image. There we go. Everybody should know this one by this point. Here, we'll go ahead and use this high definition template, as they put it. Right? Or we can use, let's see. Or we'll use this blank template over here. Yeah, why not?
That's from the original.
All right, yep, we'll save this, and we're going to go ahead and I'm going to save this as, and we'll go ahead and play around with this image because why not? Because Pokemon's coming out soon, and I'm excited about that as much as some of you are. All right, so let's go ahead and drop Pikachu in here, Pikachu.jpg, right? Now, in order to load it up, so let's go ahead and I'm going to just call this image2.py because it's the second image file we're working with. So import image. Now to load up an image, we go image, I believe is the way we do it. Let's go ahead and see. And again, I have to always work with documentation. Image.filename. So our file name is Pikachu. What kind of file was it? It was a JPEG. JPEG. Pika is equal to Pikachu.jpg. Print Pika. Okay. So what we can do. Did I mess up? Oh, JPG, right? Not JPEG. There we go. And we've loaded up our file. Okay. Now we can just simply work by just simply looking at Pikachu and looking at all of his and get data like this. So we could iterate through all the pixel values like fairly easily. For x in range, so all the x values. Well, however big the Pika is, Pikachu.Pika.get width. That will give me all the x values. And then for each row of x's, we have a bunch of y's to go through. Sorry, for each column of x's, we have a bunch of y's to go through. For y in range, Pika.get height. So essentially, this goes from down and then down the next row of pixels and down the next, or rather, down the next column of pixels and down the next column of pixels and so on and so forth. Okay, and we can do print Pika.get pixel x y, and this will print out all the pixels at x y. Right? There's a lot of pixels. And unfortunately, that doesn't really mean too much for us. Let's see, we can also do, let's also create a window for this. So let's go ahead and say the window should be as big as the image we're going to put in it. So get width, height, shock, and then what we'll do is we'll say Pika.draw draw the image on this window, and for right now, I'll just say I'll do pass and comment this out to skip it, and then a win.close, or rather click. What was it? Exit on click. And this tells it to exit only once we clicked on it, rather than trying to exit as soon as it's done drawing, which would kind of be terrible. Right, so there. So as you can see, we've loaded it up. So, but this is all about image manipulation, right? So there's a couple things we could do here with this image. One thing we could do is we could invert the picture fairly easily. Which is just simply that, well, it varies from strength from 0 to 255. So what we could do is that we could take the pixel, right? We could take the original pixel, get the original pixel, right? And then what we could do is that we could take 255 and we can subtract out the value, basically, that we are starting with. So let me demonstrate what I mean, right? So we take our original pixel and say pika.setPixel is equal to, we're going to set the x, y pixel to a new pixel. So image.pixel, which will create a new pixel. And we need a red value, a green value, and a blue value, right? One thing, actually, let's start out pretty simple. Let's go ahead and just let's go ahead and set basically the reds to 0, but keep the greens and the blues however they are. Pika.get green, Pika.get blue. Let's go ahead and just remove and set that red to 0 and see what happens. Does not have attribute get green. Oh. Or because we're dealing with the original pixel, it'd be orig. So there we've removed all the red out of this image, right? What I could do actually is let's see, can I draw multiple windows? I'm playing around with this to see what I can do, by the way. So shock 2, draw on win 2. So I'm just seeing how many of these, if I can get multiple images up, by the way. Again, basically when I play with something, the first thing I want to do is to see if I can break it. Win 2 is not defined. And it takes a bit for it to run because it's going through all the pixels and changing everything. But yeah, okay, great. So let's separate this out into the old way that pictures were done. So pictures, colors are, by the way, very, very, very difficult. Right? I'm sure you've at some point had the existential question of, wait a second, is the red I'm seeing the same red as somebody else? Right? Now, when it comes to computers, the answer is no, because there's this, because you have XKCD color, because different monitors are built differently. But basically, yeah, color models. Evolution of my understanding of color over time. Color is 3 primary colors mixed together, 3-ish primary colors mixed together, right? Red, GB, red, yellow, blue, CMYK. Or it's a wavelength in a rainbow in each color is a wavelength. Infinite Wilnate filtered through 3 eye pigments. an abstract multidimensional gamut, some four Klein manifold thing. Is that a thing? And now hopefully somebody else's problem. So the idea here is that basically color and getting color to be accurate is going to be difficult. But anyway, so it's actually pretty tricky. We would use color plates. This is one of the most famous pictures or in photography, which is basically, it's a very early colored picture. I mean, first off, let's just appreciate that it's a sad fact that men don't get to wear this kind of color, these kind of colors anymore. It's just not. People look at you strange if you wear something that's got flowers on it for some reason. But what we can see here is that we've got all these three different color plates over here, and then they get combined to produce this composite colored image, which is really cool. And yeah, so basically the black and white photographs were taken through red and green and blue filters, and then they reversed those filters, and basically it was a long and complicated process. But colored photography was really hard to do. And we got and so let's go ahead and just like split out this Pikachu into multiple windows so we can see. So we've got our original Pikachu. We'll have one window for the green picture. What we'll do is that we'll have one window for all the blues that the Pikachu picture has. And all that's going to do is I'm going to copy paste this a lot. Rather green, blue, and then there should be one for red. So red, green, blue. Okay, and now what we're going to do is that we are going to say, and this will take a couple of annoying tries, I think. So first off, we'll go through it, and we'll get our original picture. And we're going to just simply draw our Pikachu image. Then we're going to go through and draw only the reds from Pikachu's picture. So what we'll do here is we'll delete this part of what we have, but this is the part we'll simply copy paste. Get the original, go through every XY combination, get the original X and Y, get image dot, or rather get original dot get red 0, 0. And then what we're going to do is that we are going to draw the red one. And then we proceed to do this for 2 more times. Oh, right. So this needs parentheses. Get red 0 orig dot get green 0, 0, 0 orig dot get blue. RGB R G B, and let's go ahead and see what happens when we so it did the first one first because oops, shock. Oh, let's see, did I do that? Okay, so what did I do wrong there? Picket dot set pixel. I'm wondering if it has to do with the fact that like I'm setting these pixels and then drawing them. So like I don't know why it comes up as all black. Well, no, it's more like, well, what I'm trying to say is like I don't know why we get all black here because I set these up, I draw the first picture, I go over it, or is it because I've set the picture, or I've set it already? I might need multiple images as a thing, which would be a pain. Well, it was a good idea, but what we can do is we can see though that we can get the green and enough of me messing around with that. So we can, okay. Still recording? Yes. Okay. That was weird. All right, enough of me messing around with that. Let's go ahead and go back to just simply setting it up as one picture. Okay, we can just simply get the red of the original Pikachu and draw it. Actually, can I do this? Will it draw and update, or no? Will not update like that. I was just wondering if it would go through and animate it and try to change the pictures as quickly as possible. But apparently not, so going through and changing all in there. Okay, so we can remove everything but the reds, and we can remove anything but a single color. What if we instead do 255 minus original red? Kind of inverts it. So you can subtract out from 255, and what we can do is actually we can do something pretty common, which is called which is picture inversion, by saying 255 minus the original color. Green, 255 minus original dot get blue. Assuming I remember to put in parentheses, of course. And what this is that this is the inverse of that image, where basically we kind of flip the red, green, and blue values, which is pretty cool. Going back to our examples in the textbook, right, we can go through and, let's see, what is the, there we go. So there was okay, so there is a way to draw this. And so this is them doing the same thing over that we just did with inverting it, only they've got an animation going on here with this set delay thing over here. And the idea here is that basically you can get the original colors, and all they've done is broken it up into multiple steps. Basically, you can invert the color by saying 255 minus the original color to get what's called the negative. Right? If, for instance, if our original value was 10, which was a dark red, if our original red was a 10, which was a dark red, 255 minus 10 will be a very, very light red. So it changes all the lights to darks and all the darks to lights, is what it does. So we can see, so let's go ahead and say, hey, let's go ahead and do that over here. So what we have to do is draw it first. and draw it once and then afterwards. And let's go. Set delay is not implemented in your version. To animate your code, put it inside your nested loop, indented the same amount as your inner loop. Okay. So it says to animate it, then what I want to do is put it in here. I thought I had that, but we'll see. Oh, there. You can kind of see it going down there. It's going to be very slow. So we'll leave it. But it's going vertically down. It may be very hard for you to notice. But it will eventually invert. So while I'm talking over here, you notice that it's going to happen. Will. I promise. There's other different kinds of manipulations we can do, which is grayscale manipulation, which is turning it into a black and white picture. And the way we do that is that we set all the values to an average value for all three of them. So we can turn this, so how can we take any picture and turn it into a black and white picture? And you can see it's slowly still going and inverting there. Let's go ahead and set it one indentation out so it's not drawing as often. There we go. So all we're doing is just changing we're flipping all the darks to lights and all the lights to darks. Let's go ahead and see how we can turn this into a grayscale image. So to turn it into a grayscale image, what we need to do is go through. So I'm going to go ahead and instead I'm going to work with, let's go ahead and work with maybe, let's see. So let's go with grayscale.py. So again, import image. All right. Now, let's go ahead and so let's say Pika is equal to image.image Pikachu.jpg. Okay. Window is equal to this part I'm not sure. Image win. Image.image win. And then we're going to set it to Pika.get width. Pika.get height. And then gray shock or grayscale shock. Now what we do over here is that we are going to go ahead and grab all of the values, for each pixel, and then average each of the values for each pixel. So for x in Pika.get get width, right? So we're going to go through all the x value, all the x coordinates. So for range, get width. So for all the x coordinates, for y in range, Pika.get height, and for each x coordinate, this is the important part, we're getting all the y coordinates as well. Original pixel is equal to Pika.get the pixel at the xy coordinate. R is equal to original. I'm going to split this one up. Original.get red. Okay, and now GB get green, get blue. And so gray, and so now to turn it into grayscale, we average all three of those values, which should be just R plus G plus B. But remember, put it in parentheses, then divide by 3. And now we say pika dot set pixel x comma y. Set the pixel to image dot pixel GGG. So we use that gray value, this averaged value for all three of the pixels. Okay, and we're going to just see what happens as we draw. Again, we're going to see what happens as we draw it. So we're going to say pika dot draw on the window, and then we're going to go one row at a time, or one column at a time. Pika dot draw win. And so now, no such file or directory, Pikachu dot. Oh, right, I didn't save it in the right place. Alt S. Save as ITP, save over here. There we go, run it, and now it becomes black and white. Now why does it become black and white? Because what I'm doing is I'm averaging all the red, green, and blue values together, right? In gray, there's no color. So all we do is just simply set everything to be the same level of black and white. Right, when all the colors are the same, it's going to be, so when we have 0 for all the colors, what do we get? We get black. When we have 255 for all the colors, we get white. And so gray is some color between black and white. By setting the values all the same, we're making it some level of gray. If I were to set this instead to R, 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 I'd be turning it gray based off of what the red values are, right? Which still gives us something over here, right? In fact, that's what was going on in this picture over here with the Amir. Right, here was basically being set to black and white according to all the reds, then black to white according to all the greens, and then black and white according to all the blues. Then by using those colored plates, they could reconstruct this extremely colorful image by basically using some clever math and subtraction. So it's pretty cool. Now, images are fantastic for manipulate. So it's really fun to be able to manipulate images and pixels like that. So let's take a look at now like a more, at basically a much more interesting example over here. Let's see, which is, let's see, save and run. Right, so filters, grayscale, aha. So let's take a look at, and so this entire idea is basically how you get your filters on like Instagram or Snapchat. So, you know, what we just built was a very basic grayscale filter. So we'll take a look at this picture, and now let's go ahead and just re-implement it here. It's not too hard, right? The gray value is equal to, let's see, new pixel is equal to new red, new green, new blue. So the gray value is equal to what we just had, which was image, or the pixel is P, so P dot get red plus P dot get blue, p plus p dot get green. I know I did that in the wrong order, but it doesn't matter because it's addition. And then, again, divide by 3. And then all I have to do is say, this is gray underscore value. And as we can see here, now the reason that it's going across, or rather going down and doing it is because the way the book does it is row column over here, but then they do a column row over here, which I find confusing. But they're going from row to column, and rows are y's and columns are x's. So that was basically our grayscale filter that we had implemented earlier. Now, what about a black and white image? Now, what that does, now this is not black and white, this is grayscale because there's grays. Black and whites only have 2 colors, blacks and whites. So the idea here is, let's take our code for our gray value from up here. And what we're going to do here to turn it into black and white is that we're going to set a threshold. So if gray is less than the threshold, then it's all 0. If it's greater than the threshold, it's all 255. Right? So we average it out. And let's go ahead and say our threshold is, what is 250? So 256 divided by 2. So 128. I know that because it's powers of 2. So if gray value, let's go ahead and say threshold, right? Should be out here because it's variable. Threshold is equal to 128. If gray value is less than 128, then image dot set pixel, and they have column row, so column row instead of XY, and it should be and then it would be image dot, I know that we're doing it, yeah, new pixel, image dot pixel. Actually, I'll set this over here. This is a thing you can only really do in Python because you can declare variables in if statements like this. New pixel is equal to image.pixel 0, 0, 0. So in other words, if the gray value is less than 128, we set it to 0. Else, if it's greater than or equal to 128, pixel is equal to the maximum value. And then we're going to go ahead and say new pixel. Save and run. So now, notice that it's not turning gray. It's either black or it's white, which leads to some very interesting decisions, like such as little individual bits of chain just hanging in the air by itself and then disappearing. So basically, that's pretty cool. And it all depends on how we change this. So let's go ahead and say set delay to 0 and change this. What if we change the threshold to be 200 instead? Save, run. Going through, figuring it out, thinking about it. All right. So here's another one called sepia. Everybody remember sepia, or what is it, sepia or sepia? Sepia. Sepia is this color. It's a reddish brown. Oh, so that's where it comes from. The ink sac of the common cuttlefish. Okay. Very old things using sepia ink. So the idea here is that how do we figure it out? Well, it says basically what we do is that here's a formula to convert it into sepia tone. Basically set the red equal to the red times 0.4-ish, then 3/4 of the green, and then a bit of the... So basically balance it. It's telling you to balance out the colors a bit more. So okay, so we get our pixel. R is equal to... Okay, so R is equal to... Let's go ahead and actually do this fairly easily using copy-paste. R is equal to P dot get red. And I think this will be the last example I can do, and then I'm going to move on to more nested loop stuff. P dot get red, get blue, G is equal to P dot get green. And then the reason I did it all capitalized is because these are all capitalized, and now I can copy paste this over here. And then all I have to do is replace these weird crosshatch multiplication signs with the real multiplication sign. And now, image new P is equal to image dot pixel new R new G new B, and then set image dot set pixel call row X and then new P. Okay, and now we can run it, and hopefully I didn't break everything. And there, as you can see, because I followed the formula for sepia, it's just simply it's going and applying a sepia filter to everything. So that's pretty cool, right? So there's other things you can do here, like you can rotate images, you can do other stuff. And I think this is a very good project to take a look at. We might come to it later, but for right now. But as you can see, we're iterating fairly easily through a two-dimensional image or a two-dimensional piece of data. Now we've done this a lot, actually, when we've gone through, like, you kind of done it a lot without realizing it, especially when we've done the hurricane tracker, where basically we're going through, well, when you were going through the CSV file. Because if you actually think about it in a weird way, that CSV file is just a 2D grid of characters. And iterating through them in a specific way is all you're doing. Now, data in Python can be nested. So, for instance, Python 3 over here. A lot of this stuff gets stored internally. Let's actually see. Can I just want to see one thing. If I do Pikachu, if I do, for instance, Pika.77, will that work? Can I do subscript notation on that? No. Images are not subscriptable. So we've done dictionaries and we've done lists, but what we really haven't actually taken a look at is nested lists. Now, nested lists are lists of lists. We have done lists of strings, though, right? So maybe that's a good place to start. So let's go ahead and actually do like classroom, ITP, nested lists. So let's go ahead and take a look at an example over here. We've got, for instance, the following. List is equal to a bunch of words, hello, comma, world, comma, how are you? And if we wanted to print out one letter of this list each, at a time, it's fairly straightforward. We could actually, first off, we have to go and say for word in list, right? Like that. And we would just, if we wanted to just print out each word, we would go print word and then hello world, how are you? That makes sense to everybody, hopefully, by this point. But what if you wanted to go through each character in each word? Well, for each word in list is the way to read that. Now, for each character in word, print car. And we get hello world, how are you? Just printed vertically. Lists of lists work by the same kind of idea here. By the way, the white space is totally optional, right? At least for these kind of stuff, for like putting scripts between things. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a list of lists. Looks kind of scary for you at your first glance. But notice that Python has no problems with it. 1, 2, 3, 4, 5, 6, 7, 8, 9. No problems there. What can I do with it? Well, I can go and iterate through it like this. We can print, let's see. We can iterate, it's a better way to think of this is as a matrix when we're dealing with the lists of lists. So for instance, for row in matrix, in LST, print row. And if we do that, it becomes a bit more manageable. Here's each row printed out. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what the list of list is. A bunch of 2D dimensional things. But again, what we were looking at earlier was actually a lot more complicated with the pictures. What we were looking with pictures was a matrix, but instead of having a number for each point in the matrix, we had 3 numbers at each point in the matrix, right? A red, a green, and a blue. A whole pixel. A 2D thing of pixels. That's what a picture is. So in a way, that was way more complicated, but this being a bit more abstract seems to fill people with dread a bit more. So this will be the subject of I think, Thursday's lecture in a bit more detail, because the image processing really, I think, was helpful for kind of the idea of how to go through something, getting us back into working with nested loops a bit more. So on Thursday, we're going to go into nested lists in a whole lot more detail. So, because that's really all I have left to teach you that needs to be done according to our course curriculum.